Hello everyone, welcome back to the operating system series. In the previous videos, we learned FCFS, SJF, and in SJF, a variation SRTF scheduling algorithms. Today, we are going to study another important CPU scheduling algorithm called priority scheduling. Priority scheduling works on a very simple idea that every process will be assigned with some priority value. And here, the CPU is allotting the process with highest or the lowest priority. Based on the importance of the process, the priority will be assigned. One point to understand here with respect to this priority assigning is, if the number is small, if the priority number assigned to a process is small, then it has the highest priority. Simple thing, if process 1 is assigned with 1 and if process 2 is assigned with 5, it means P1 has the highest priority and P5 has the least priority, talking about these two comparatively process. So P1 has highest priority and P2 has lowest priority. So this we have to understand very clearly. And here, priority scheduling is widely used in systems where certain tasks are more important than others, such as real-time systems. So that is the reason we use priority scheduling. And one more thing, previously, if you remember, in FCFS, we saw something with respect to FCFS, we had something called as convoy effect as a disadvantage. And talking about SJF, we have starvation as one of the disadvantage. Now, what is starvation? Let us just understand the disadvantage about starvation and then go forward for the priority scheduling. Now, what happens? Just assume that with respect to SJF scheduling algorithm, here P1 has 25 bus time, P2 has 3 and P4 or P3 has 4 bus time. So obviously we know that P2 will be executed first and next comes P3. Now at the time P3 is executing, I might get two more process P4 and P5 with bus time as maybe 8 and 6. So what happens? P1 continues waiting. After P3 it will be P4, then P5. At this time again, if P6 comes with lesser bus time compared to P1, then P1 again has to wait. So this is called as starvation, and P1 will end up starving forever. And forever in the sense until we get a next burst time, next process with a higher burst time compared to P1. Then only P1 can execute. If I get 100 process with lesser burst time, then again P1 has to wait. This is one disadvantage in SJF, which is called as starvation. Now here, let us understand. Again, talking about priority scheduling, again I can tell priority scheduling can be preemptive, non-preemptive priority. It can be whichever as per the requirement. It can be preemptive, it can be non-preemptive. So before we start executing or start solving a problem, we'll just understand. Talking about priority scheduling, CPU will allot the priority and each process it will tell it has the highest priority, this has the lowest priority, all those things. And talking about characteristics of the priority scheduling, as told, all the process will be assigned with the priority and highest priority process will execute first. Again telling, if the priority value is small, then this will be having the highest priority. If the priority value is greater, larger number, then it will be having lowest priority. So this we have to understand. And in priority scheduling, we have this preemptive and non-preemptive also, so it should not be a problem. And yes, we know that shortest job first is a special case of priority scheduling. Why? Because if the burst time is shorter, then it has highest priority. This is a kind of special case that is there. So this is what we have with respect to the theoretical aspect of the priority scheduling. Now we'll solve a problem. We'll understand an example problem here. I have 5 process with burst time P1, P2, P3, P4 and P5 with 10, 1, 2, 1 and 5 respectively. And here, when I talk about priority scheduling, we are not that much bothered or worried about the burst time because we are looking into the priority aspect here. If you see, I have priorities as 3, 1, 4, 5 and 2 respectively for 1, 2, 3, 4, 5 process. So you would have an idea now which has to come first. The lowest number has the highest priority. So in my Gantt chart, as you people already know, we have this Gantt chart. Step number 1, we are doing the Gantt chart. I will write the Gantt chart first. We will be taking P2 problem first, starting at 0 milliseconds. Now, I'm assuming all of them came at the same time. So 0 milliseconds, I took P2 and the burst time requirement is only 1 millisecond. I complete it. Then I have 1 is done. Now I'll take 2. Second priority is P5. It is working for 5 milliseconds of burst time requirement. So 1 plus 5, 6. After that, I have third priority process P1. Burst time of 10. So this becomes 16. Then I have P3 of requirement 2. So this becomes 18. And last comes P4 because it has priority as 5, larger number, lowest priority. I got P4 with only 1 requirement. So this becomes 19. If you see here, 10, 11, 12, 13, 14, 14 plus 5, 19. So this matches the tally. Now you people know the second step is calculating the average waiting time. And we'll not worry on calculating the average waiting time here. The waiting time is calculation of waiting time is quite simple here. We'll not worry on that so much. P1, we know P1 waited for 6 milliseconds. No separate arrival time, so we'll not subtract that also. Then I have P2, that is 0. Then I have P3, that is 16. Then I have P4, which is 18, and P5, which is 1. So this becomes 6 plus 0 plus 16 plus 18 plus 1 divided by 5. Why 5? Because we have 5 process. We have 5 different processes that are there that we are doing. So it is 6 plus 0 plus 16 plus 18 plus 1, which is 41 divided by 5. 8.2 milliseconds. Then talking about the third one, calculating average turn around time. P1, when did it complete 100%? 16 milliseconds. P2, 1 millisecond. Then P3, it is 18 milliseconds. P4, it is 19 milliseconds. And P5 is the last one, that is 6 milliseconds. So it is clear that we can tell it is 16 plus 1 plus 18 plus 19 plus 6 divided by 5. This total becomes 16 plus 1 plus 18 plus 19 plus 6. It is 60 divided by 5, which is 12 milliseconds. So it is 12 milliseconds. 8.2 milliseconds of average waiting time, and we have the Gantt chart here. So here, as told, this works on the priority basis. Whichever priority we have, based on that, we have to work here. So this is a non-preemptive process that we have. In this, again, we can have a preemptive process wherein We will have an separate arrival time given. Based on the arrival time, what we can do is we can make sure that we stop a process, we can make sure that we preempt it and allow one more process. So this is with respect to priority scheduling. We saw how to solve a priority scheduling and all those things. Now, with respect to the disadvantage, we got to know that yes, we have priority for each and every process. But what are the disadvantages that we have here? Again, when I talk about disadvantage here is again starvation. See, I'll just tell you here. P1 came first, but it had to wait until two processes complete the execution. Why? Because it has less priority. Now, because of this, we have a problem called as starvation. We have a problem of starvation. So this is the problem again that we are facing in a priority as well. We saw this in SJF scheduling. Now in this also priority scheduling also we are getting the same error or disadvantage. I would not tell it as error, it is a disadvantage that we have. I hope you people have understood. Please solve more and more examples. In the next video, we will also study on round robin scheduling, which is one of the most widely used scheduling algorithm with respect to time sharing systems. Thank you for watching, people.